Hello. In this screencast, we will quickly review the properties of the base 10 logarithm and then identify the properties of the base e logarithm, which we call the natural logarithm. In our previous work, we let y equal p of t equal 10 to the t power and L be the inverse of p. We reviewed properties of inverse functions and introduced a new name and notation for the inverse function L. Pause the video and recall our previous work. Okay, so we know that if p and L are inverses, then y equals p of t says the exact same thing as t equals L of y. And this is because we know the inverses say the same thing from two different perspectives. We call L the base 10 logarithm, and writing y equals 10 to the t is the same as writing log base 10 of y equals t. When we write log base 10 of y, what we mean is the power to which we raise 10 to get y. Previously, we also used our knowledge about the properties of y equal p of t equal 10 to the t and the properties of inverse functions to identify the properties of the base 10 logarithm. Pause the video again and recall the properties of the base 10 logarithm. Okay, so in our previous work we saw that the function L of y equals log base 10 of y equals t has the following properties. The domain is all real positive numbers. The range is all real numbers. Log base 10 of 10 to the t equals t, and 10 raised to the log base 10 of y equals y. These last two properties are true because, again, we have two inverse functions. They're going to reverse each other's processes, so the input and the output end up being equal. And then lastly, log base 10 of 1 equals 0. If you don't remember why these properties are true, it would be a good idea to watch or rewatch screencast 3.4.2 before moving on. The base 10 logarithm is a good starting point for understanding how logarithmic functions work because powers of 10 are easy to mentally compute. We could similarly consider the powers of 2 or the powers of 3 functions and develop corresponding logarithms of base 2 or 3. But rather than having a whole collection of different logarithm functions, we're going to develop a single logarithm function that we can use to represent any other logarithmic function. In correspondence with the natural exponential function e raised to the t, we now develop its inverse function and call this inverse function the natural logarithm. So here's the formal definition of the natural logarithm. Given a positive real number y, the natural logarithm of y is the power to which we raise e to get y. We use the notation natural log of y to denote the natural logarithm of y. We can think of the natural logarithm as the base e logarithm. For example, if we want to know the value of the natural log of e to the negative 3, we can rewrite it in exponential form instead. We're looking for the power to which we raise e to get e to the negative 3. And that power is negative 3. So the natural log of e to the negative 3 equals negative 3. Or if we want to find the value of e raised to the power of natural log of negative 5, we could rewrite it in natural log form instead. We're looking for the natural logarithm of some number that is equal to the natural log of negative 5. Well, that number must be negative 5. In other words, when we raise e to the power to which we raise e to get negative 5, we get negative 5. When we developed the properties for the base 10 logarithm, we used the fact that the base 10 logarithm is the inverse of the powers of 10 function. In the same way, we can use the powers of e function to develop the properties of the natural logarithm function. From previous work with exponential functions, we know that the domain of y equals e of t equals e to the t is all real numbers, and the range is all positive real numbers. Because n of y equals the natural log of y equals t is the inverse of function e, we know that the natural logarithm has a domain of all positive real numbers and a range of all real numbers. Next, we should also mention that e to the 0 power equals 1, and using the notation of logarithms, we can say the same thing from a different perspective. That is, the natural log of 1 equals 0. Lastly, we can use what we saw in the previous slides as well as the properties of inverses, namely that they reverse each other's processes, to simplify the natural log of e to the t equals t, and e raised to the natural log of y equals y. In future videos and work, we will use the properties of the base 10 and natural logarithms to solve exponential and logarithmic equations.